I first of all welcome everyone for this talk. I'm really glad to be one of the presenter at Extreme Python for this year. Let me give you a brief introduction about what I do for living. Uh, I work in a field of geospatial data, which means that day in and day out, I talk a lot with the location data, depending upon what you want to do with it. So there are in past couple of years, the use case of location data and of course the importance of location data for different businesses and different purposes has grown exponentially. uh, right now, if you think about it, whatever search that you do, doesn't matter if you do it on Google or on YouTube, every single search uses location data some way or another. YouTube will always recommend you the video that are recorded by YouTubers within your region. So that is one of the use cases. Companies like Uber or Zomato, all of these companies have location data as their core business center. That's why it's important to understand the geospatial side of the data. And if you are working with Python for a long time, this 30-minute talk is just going to open another world of possibilities that you can work with, specifically in Python. As I mentioned, if you wanna follow the code, you are more than welcome to check out the GitHub link. And if you want to connect with me, you are more than welcome to visit my link and set up a meeting. So let me just tell you what exactly are the steps that we are going to talk about today. First of all, we'll start with a baby step, which is understanding the GIS concept and Python concept. I'm pretty sure I don't have to explain anyone what is Python, at least at the Extreme Python conference, but it'll be really helpful for everyone to know some of the very basic GIS concepts. Then we will see GDAL and OGR and what that has to do with the geospatial analysis. Then we will see a little bit of vector data analysis. I think this is the place where majority of the geospatial analysis will happen. But of course, raster data analysis also has its own important role. And finally, we will see how we can create interactive maps inside our Python notebooks, just so that we can create a interactive environment for our data to visualize and also play with it. So what the hell is GIS anyways? As I mentioned, GIS is more or less working with the location data. And when we think about location data, it's usually divided into two major parts. First is your vector data, which is any data that we can store, for example, in database. So if you consider your location, whenever you share your location with someone, you will be sharing bunch of numbers as a latitude and a number as a longitude. So these are not just numeric values. They hold some more information, which is your position on the earth. So just like point data, we also have line data, polygon data, and these types of data. Usually we save them in different extensions like shapefile, GeoJSON, KML, uh, and then we have a raster data as another side of the coin. So these are usually the imageries that we get. One of the simplest example can be if you open Google Maps and if you decide to switch from your street view to satellite view, you will actually see the earth as it is. You will see the mountains, you will see the greenery and things like that. So that becomes a raster data. A lot of the calculations and a lot of the analysis also happens on raster data, in terms of getting the information about a bigger area. Consider a scenario where you want to keep an eye on an entire forest and understand where might be the region where you have to take care of forest fires. All these thousands and thousands of hectares of data has to be examined and inspected, and raster data is something that helps us to do that. Now, few Python concepts that you need to know in order to start geospatial analysis can be basic concepts such as what are variables, data types, how to write loops, how to add conditions, how to create functions, classes, objects, and finally how to take advantage of decorators. A few very famous and used by almost everyone packages in Python are NumPy, Pandas, Matplotlib, and Plotly. I don't have to convince you that using NumPy or Pandas can help you to uh, help you to basically do the calculations faster than using traditional lists and things like that in Python. So if you know these basic Python concepts and if you know these packages, you're ready to start your journey as a geospatial analysis analyst and developer. Of course, there are few packages that are developed just to focus on geospatial uh, uh, just to focus on geospatial domain, and we will be discussing about those packages in this talk. Now, as I said, GDAL and OGR command line tools. So if you think about it, GDAL is a godfather of all the major geospatial tools available in the market today. GDAL is a library which allows us to translate and analyze raster and vector data. GDAL can be installed on any machine and can be used via terminal like a command line, or we can also download different packages. There are packages available for Python, for JavaScript, etc. One of the very simple use case of GDAL can be converting your data from one form to another. Say you have data in a KML format that you want to convert it into another format, GDAL is the way to go. There are so many things that we can do with GDAL is that almost all major softwares that are available for GIS domain right now uses GDAL some way or another. A very famous open source software known as QGIS uses GDAL as a base library. So does Esri's ArcMap. Esri is one of the best company that you can see in the GIS domain right now. So the point being here is that once you understand GDAL and once you understand OGR and their command line use case, your life becomes very easy because you don't have to open software and run it for very basic commands like data conversion. You can just do that using command line, and it helps you to save a lot of time. I recently worked on a similar project where we had more than 50,000 KML files. So that is a data format that my client wanted to convert into shape files, another data format. Since they didn't know GDAL, they were actually using software to do it one by one. But just within a few seconds, I wrote them a shell script which uses GDAL command line, and the job was done within 15 minutes. So you can see that how easily it can save the life. And as I said, it's very important to understand GDAL and OGR before moving forward into geospatial domain, because these acts as a baseline for a lot of the packages and a lot of the softwares. Now let's focus on vector data for a bit. As I said, vector data is basically data which has a lot of numbers in it. As I said, but those numbers holds the values. So it can be a longitude, it can be a latitude. And the libraries that we use in order to deal with that data, or in order to deal with such data, are GeoPandas, Shapely, Fiona, etc. So as you can see, GeoPandas is basically an extension of Pandas library focused on a geospatial work. If you have worked with Pandas in the past, it manages your data in a very systematic fashion, and which allows us to do various types of analysis with the data. So GeoPandas is just extension to Pandas, where then you can treat this latitude and longitude data in a way it is supposed to be treated. For example, rather than just treating it as a number, it treats it as a location, and then you can do bunch of things like find me all the data within 5 kilometers of my current location, or find me all the data which is inside any another polygon. So all these things become very easy when we use GeoPandas. Apart from Pandas, GeoPandas also uses library known as Shapely and Fiona. Shapely is a library which actually deals with the shape. So Shapely actually understands the polygon or the lines and the points. As I said, we can load our previous data. We can also create our own data. We can perform spatial operations. As I said, we can see whether some points are within another polygon, or maybe some lines are intersecting another lines, things like that. And we can obviously visualize the data using Matplotlib and GeoPandas together. So there are various ways we can get our spatial data into the GeoPandas. First of all, we can load it via disk, very straightforward. So if you see the code, it looks very similar to the pandas. We will be reading a file, and the beauty is that it will read the file and it will automatically get the idea that which of your column is a geometrical column, and then it will deal with that. You can also use your database to get the data. For example, PostGIS is one of the best open source relational database you can have. You can use that to store your geometrical data and then use PsychoPG to load it, and then of course GeoPandas to read the PostGIS data directly. You can see that GeoPandas and Postgres works so well with each other that they actually have a function just for the Postgres. Apart from that, we can also create our own data on the fly. As I said, most of the time, if you're not from a geospatial background or if your company is not into GIS, most of the time the data that you will be getting will be a CSV where you will have a column for longitude and a column for latitude. In that case, you can simply read that CSV using your pandas and then convert your pandas data frame into GeoPandas by using the command for geometry as points from X and Y. And then you can simply pass the longitude and the latitude, and uh, you'll have your data frame ready for you. Or last but not the least, you can always create your data frame from the scratch. Now here, to create geometry, you can see that we will be actually using Shapely. So Shapely is a library, as I said, which also is used to create a GeoPandas library. So Shapely takes care of all the geometrical data. So you can create point, line, polygon, multi-polygon, multi-line, and things like that using Shapely. So here you can see that I have created a Python dictionary with a geometry, again, which is a list, and it contains points. I can also add lines and polygons, and then all other metadata related to it. So once we load the data, this will look just the same how we see the pandas data frame. So you can see in the screenshot, it is just like a pandas data frame, but it has a geometry column attached to it. And then we can perform all the operations that we generally do with pandas also on a GeoPandas data frame. So for example, I had a countries list where I had the countries from all over the globe, and then I can just get India out of that by simply doing countries where admin is equal to India. Straightforward, nothing geospatial about it, just a pandas operation. But now what I can do is I can take that pandas result, and then I can squeeze my geometry out of it. So now I'm just interested into geometry of India, and then it will give me the actual shape of India, and then this shape is actually in a Shapely format. So once I have that, then I can run that shape against any other geodata frame. For example, I also had a GeoPandas data frame with airport, and as you can guess, it had lat long for all the airports across the globe. And since I'm interested into just seeing the airports within India, I don't have to actually look for the metadata where then each airport will have a country assigned to it, and then I'll do the countries is equal to India. What I can do is I can simply take the geometry of airports and the geometry of India shape, and I can do within. So all the airports within India are then listed below. So you can see this becomes very easy since you are using a geometrical data. The life becomes very easy. You can perform a lot of special operations. Within is just one of such example, but there are quite a few operations that you can do with it. Next we have is a visualization of the data. So far, the data that we had was just looking like a pandas data frame. There was we were not sure whether the geometry is actually there or not. But as soon as I put that data frame into matplotlib, it will actually show it on the map. So you can see that right now, even though it looks like a world map, under the hood it is just a plain matplotlib plot. But the geometry is then treated to create the actual shape that we are seeing. And then I have colored the continents based on the column continent, which is again a matplotlib property. We can combine multiple layers on top of each other. So on the right hand side, you see that we have a base map of the countries, and then I had a cities I had a cities layer as well, which was a point of all the popular cities. And then you can see that all these red dots are actually the point on the cities. So you can see that once we have the data coming from any source, as long as it has a valid latitude and longitude, or a valid geometrical data in it, we can do so many things with it just using GeoPandas. If you want to take any advanced analysis, you can then actually use the libraries such as Shapely to actually go inside the geometry and then perform operations based on that. Here, using GeoPandas, we can also perform operations where then we can create a new data frame based on the query that we are building. For example, if I just want to separate the India, then I can do, as I mentioned, I can do countries, where then, or let's say a better example of using GIS data can be, if I want to get all the countries that touches India or Indian border, then there is no non-special way to do that. We don't have any column where we have written that the country is touching and then India in it. In that case, we will have to use the geometrical capabilities of GeoPandas. So in that case, what I will do is I will grab the Indian shape, and then I will run a special operation known as touches. So all the countries that touches the India's shape can be then listed out. So this is a power that geospatial data basically holds. And as I said, we can always also work with raster data using Python. There are so many great libraries available, such as Raster.io, EarthPy, Google Earth Engine, which helps us to deal with the imagery data that is available, and it keeps on getting updated every now and then. And then we can process on that data in order to derive result. One of the projects that I'm working on right now is related to an agriculture department, where they will get the imagery for the entire India every 5 days, and then based on where the farms are located, we will calculate different indices. So indices such as NDVI value, and things like that. So these indices plays a vital role in order to understand how the farming is going on, and what preventions or cures that we need to suggest to the farmer in order to optimize his time and efforts into the farming. So this is one of the huge use case that we have with dealing with the imagery data. A simple example of dealing an imagery data is that if we have a TIFF file, TIFF is again an imagery format that usually we use. We can get a lot of information from that TIFF file. So for example, in which coordinate system does it belong to, how many bands of data does that image holds, what is the bounding box of that image, what are the height and width criteria of that image, and so on and so forth. Then we can actually read each single band. If you're not from geospatial background, this will not make much sense to you. But if you just search for example, after the conference, if you just search for NDVI calculations using imagery, you will see what are the applications of it. We use infrared, we use red color, green color, blue color of images in order to derive various indices. But if one thing that you will notice over here is that even though we are loading the data as a raster data, as a imagery data, ultimately we are converting that image data into a NumPy array, which actually gives a lot of flexibility in order to do calculations, in order to do the analysis on the data, and then derive our result based on that. And that is where Python comes into the picture. So I can basically clip the raster data based on the geometry. Like I can take a vector data, for example, my farm, and then I can take the imagery of the entire world, and then I can clip just the imagery that I'm interested into. So by doing that, I'll get the imagery that I want to work with, and then I can do a lot of analysis based on that. For example, we can get a histogram of the data in order to see that what is the DN for, and how many times it is getting repeated. So it becomes very important to use Python while dealing with such type of data, because then you can play with it using the NumPy's processing power. You can play with each one of the pixel, and then do analysis on top of that. Finally, as I said, we can also create interactive maps based on Python's libraries, such as such as iPie leaflet, and things like that. So what we do over here is that whenever we want to present our findings, if you remember from our earlier slide, here in the visualization, we were actually just creating a plot. So there is no life inside this plot. It is, at the end of the day, it is just a plain old image. But by using interactive maps, we can actually create movable maps inside our, uh, for example, Jupyter Notebook only, which becomes helpful from time to time, where you want to present a lot of data to the user, and you want to give user an ability to play with the data. So for example, in this example that we see over here, we have this all cities data. So it's a point data of the all cities. Then we have all countries data. That means all the polygon of the countries of the entire world. And then we will just take the India out of it. And then what we will do is we will take all the Indian cities, and then we'll add those on the interactive map, so that I can move my map, and then I can see each one of the city. So one of the advantage of interactive map is that you can zoom in, zoom out, and that becomes very important and a fun thing to do. So here what I'm doing is I'm using IPy leaflet library, and I'm creating a map. And then for each Indian city, I'm creating a marker, and I'm adding the value to it. That means what text should we see when we click on the marker, and then I'm simply adding the marker to the map. And as you can see, we get the map, where then we have this base map, and then all these markers of the cities within India. And the fun thing is that we can move this map. We can zoom in order to see just one city, or we can zoom out in order to see all the cities. And apart from that, we can then again also click on any one of the marker in order to see the information about that. And finally, we also have a very good library known as PyDeck. So PyDeck allows us to create high level visualization based on our data, using a library known as DeckGL. So DeckGL is a JavaScript library, and PyDeck is a Python version of that. So here you can see that we can now see our data in a sort of like a 3D way, where then you can tilt your map in order to see the intensity of the data. So what we are doing over here is that we have the journey data, where we have the starting point and we have the ending point, and we want to see that how many times from start to end a person has gone. So you can see that the radius of the arc depends upon the intensity of how many times the transaction has happened. And by visualizing it in a 3D, it becomes very helpful, and we can immediately start sorting out which are the arcs with the maximum radius. So it becomes very easy for us to do analysis and visualize our data in a way that anyone who looks at the map can make sense out of it. Rather than just seeing the data in a tabular format, we can actually create an interactive map, which basically makes the life easy. So this was a journey of few things, very few things that you can do with geospatial analysis with Python. There are tons of more libraries, tons of more use cases, and there are specific solutions designed just to focus one of the problems. So if you have any questions about this, feel free to ask or write in a chat box. If you want to talk with me, you can find me on all social media. Here's my handle, here's my email ID, and GitHub link. So thank you everyone for attending. If you have any questions, please shoot them.
Kishan, I have a question. Hey, fantastic presentation.
Sure.
Love the way you presented
Thank
this
you.
one.
That's why I have written on the first slide that I'm really bad at presentation. Here you
That's
go.
the reason I told you this.
Nice.
I saw that. I saw this. Please, yes. Okay, good. So Krishna, tell me this. Like, how do Zomato and Uber and Ola do this? Like, for example, if I am having a GPS location, let's say X and Y coordinates or lat long coordinates, if I want to draw a circle of, let's say, hey, tell me everything around the radius of 50 kilometers. So does Shapely could do this kind of stuff?
Okay, so I will answer your question in two parts. First is the second part is whether Shapely can do this. So Exactly, Shapely can do this. Shapely basically will take all the shapes that you're interested in. So one shape can be your own location with a buffer of 5 kilometers, so that becomes a circle, and then
Yes.
another file of all the locations that you have, and then it will quickly get all the points that fall within your circle. So Shapely can do that.
Mm.
Answer to your first question, how exactly Zomato or Uber Eats do this? There is a very good library that Uber has created known as H3, which basically
Mm.
means that they have divided the entire world into hexagons. And whenever you see surge in the price, whenever you're ordering their cab, it basically depends upon in each hexagon how many users are requesting and how many cabbies are present. So
Mm.
depending upon that, they will either color the hexagon as red or yellow as green,
Mm.
and then depending upon where you are and what is the color of your hexagon, the value will change. So you can see here you have the data, here they have their hexagons, and here how exactly Uber sees that data.
Fantastic. One more question I have. So, what's your favorite tool to get the geospatial data? Like, is it Google Maps or do you use something else for experimentation?
No, generally I work in open source domain, so Google Maps is sort of like hates me. But I try to get my data from Natural Earth, a very good website, but it has very limited data. Naturalearth.org. It has all the data that I presented in the presentation comes from here. So they have few data sets available with them, but more or less,
Or
usually
maybe let me
the
ask,
only
like, is there
problem.
any like open source equivalent of or competitor of Google Maps where we can get all the position data, like POS data?
Exactly. You can use OpenStreetMap. OpenStreetMap is an alternative of Google Maps, and the beauty of OpenStreetMap is that it is built by the people, for the people. So all the data that they have for OpenStreetMap is available for free of cost, for you to download. Any other websites that you see, for example, Mapbox, I'm not sure if you have heard of that or not, uses this data, and then they will add their own data on top of that. So all this data that you see over here can be downloaded depending upon what you need from them. I'm not remembering the name exactly. I might have it in my bookmark, but there is, okay, it is known as Turbo OpenStreetMap. So what does this do is, this is sort of like an SQL which will allow you to download that data. So you can do something like, okay, give me all the schools within India. So all the data that has the name schools written in it will be returned to you, and then you can use that data wherever you want. It's 100% open source data. So this Overpass Turbo, it's just little hard to understand the programming that they do. But for example, here for this map, what we are seeing, I want to get all the amenities with the drinking water as a tag. So I can simply run this, and this will just give me all the data. So you see all these circles. I can go ahead and then I can just export that data. For example, I can get it as a KML or as a GeoJSON. There we go. And I have that data with me. Then I can use it wherever I want. That should not be a problem.